Thanks everyone for joining the April 21st PodSecurityPolicy Replacement breakout session. I think we are coming close to being able to mark this thing as implementable, or merge it at least. So before we go through the kind of the outstanding unresolved issues, is there any particular topics or concerns that anyone wanted to discuss today?
I was interested in two aspects. The integration with SE Linux by default, because I saw there was an update and I honestly don't know what the update means to me. And also how volumes, whether we're going to try to do anything with volumes, whether or not in terms of either exemptions or something.
Yeah, that sounds good. I'd also like to touch on the capabilities discussion that I just added.
Yeah, I was going to mention that. Thanks, Tim.
Anything else that anyone wants to make sure to cover? Actually, I'd like to touch on the Windows conversation as well. I'm not sure if, I see Ria's here. I'm not sure if any of the other folks that were involved in that discussion are here.
Yeah, I just pinged some folks. Let's see if they're available.
Okay, thanks. Was anyone from SIG instrumentation able to join? I just pinged that channel again to see if we can get some input on the question of metric cardinality. I think that's kind of the main open question there. I put that as blocking, but I'm actually not sure that needs to be alpha blocking. It's probably something we could resolve on a PR, at least.
Yeah, that seems like something that would be beta blocking, like having the metrics solid and before it's enabled by default. Seems important.
Yeah, agreed. We have a concept of like alpha, beta, GA metrics now too, right?
It's just alpha and stable. There's no beta.
Okay.
From a metrics perspective, like once it's there and you've written stuff against it, like saying, oh, it was enabled, but it was beta, so we're changing it. Like I get that that's not a useful.
Yeah.
So,
but at least,
yes,
we can at least say these metrics are subject to change.
Yes.
Okay. Well, in that case, let's maybe start with SE Linux. Let me scroll down to, yeah, so Jordan, you had an open question about what would happen if type is unset. Actually, maybe before we do that, let me just give an overview of what we currently have there, since David said he was a little confused. Sorry, 1 second, I find that. Yeah, so what the current proposal that's written down here is, it's basically saying you can set, well, so unset SE Linux options is allowed. So SE Linux options is a field on the pod, or I think it's pod security context and also the container security context.
Yeah.
And so you can, if you do set it, then type, this is what's written here, is type must be set to one of these 4 values. Level can be set to anything or left unset, I think. And role and user must be left unset. Yeah.
Yeah. So I think if I got like Jordan's question correctly, like can we keep the type unset as well? And yes, we can, because the container runtime will pick the default for you.
Okay.
Yeah.
Okay, so type is optional, but if set must be one of those 4 values.
Right.
level is also optional?
So level is, I mean, so you can't, well, yeah, so level is also optional. If you don't set anything, like container runtime will pick a random one for you.
Okay.
Yeah.
Okay.
And we
That sounds
probably
good.
don't want to allow setting user or role for baseline. Like, okay.
And is the reason for that user and role, like there aren't well-known values like there are for type, and
Yeah.
could use that to escalate things, or?
So they just like haven't been used for containers in any meaningful way so far, and we don't know of a use case so far. So like the type level restriction that we have is good enough. Like I, I can't imagine us using that. Like if in the future it changes, we may have to revisit this. But today, like the system you and the defaults that are used are enough for container isolation. System you object are.
And level is not escalating. That just,
Yeah, it's just within that container T, you're subdividing it into multiple random pieces, and by default it's random. But if you want to do enable sharing or something, then if we allow you to modify it in baseline, then you can do that.
And so to switch level into an attack on somebody else's pod, what would I have to do?
You would have to know the level for the other pod and then set the same level for your pod. And then possibly if there is any kind of inter-process communication or something, or if there is any breakout, you may be able to read any files written by that pod.
Okay, so let me just make sure I've got it. In a normal case where we say someone is not broken out of their pod, being able to specify your level allows you to have two pods which can do things like share a volume mount and
Right.
have that piece work. Or if you control both of them and put them inside the same PID namespace, they can communicate. Some sort of inter-process communication you spoke about?
Yeah.
Okay. And in order to have someone exploit this, they would have to know, you would either have to be sharing a volume mount, which wouldn't happen unless you had already decided to do that, or there would have had to be a bug somewhere else that allowed you to escape from your container and mount their file system. Okay.
Yeah, escape your container and then directly access the rootfs of the other container. So that would need like a CV level.
Okay. And we would choose this as baseline instead of restricted, because there is that case if you have one bug in a container runtime and someone knows the level that they would choose from some other namespace and they're able to exploit that bug, they could attack it. And that's why it's not restricted. Do I have that right?
So this gives some flexibility, like at least for the types that like we can pick one of the other labels. Like one good example is the container log reader T. So that is like a more restricted one, or like it basically gives you access to just reading log files.
So this, by allowing these specific types, another admission plugin could certainly add constraints, right? Like around, like forcing it to be log reader, or forcing level to be unique per namespace, or something like that. Without that other admission plugin, though, just with the baseline policy, by limiting type to these container-specific types, we're basically saying you can set level to things and cooperate with or access things from other containers if you can mount them in or get access to their IPC.
Yeah. And then restricted, we wouldn't want them to do anything. We just let container runtime choose a random unique one for you. So you're not able to override that.
I don't think that works well, because that means that another admission plugin, like the one OpenShift has, that says things in the same namespace are assigned to the same level, wouldn't be able to do that.
That would be a problem.
So maybe in restricted, we allow just changing the level.
I mean, how is that different from baseline? That seems the same as baseline to me.
Yeah, I mean, type is the only thing that gets open then. Yeah, and there isn't, it's not much different then. Yeah.
I'm fine with leaving this as the same level, or the same restrictions for restricted and baseline.
Bounding to container type seems like a good boundary for something that doesn't have specific knowledge of a cluster-specific allocation strategy.
So you're saying that because we bound these particular types, allowing the selection of a level in restricted is a reasonable trade-off to make. It requires a second bug, pretty significant second bug, in order to do anything with.
Restricted significantly limits the volume options you have. So in baseline, you could mount like NFS volumes, and like you can mount a lot of different things in baseline. So baseline is already sort of allowing access to volume types that sort of would let you like mount in data that other containers might be involved with. Restricted limits those volume mounts a lot. Yeah.
Yeah, but I think probably like even limiting the types in restricted may make much more sense, like because the other ones is the init T is for allowing someone to run a systemd inside a container. The log reader T is like strictly for reading logs, and the KVM-T is for running things like Kata, which like they add one more level of VM security. Which I mean, so restricting it to just container T probably doesn't make it any more safer in restricted.
I don't know, like container and non-container, that's a bit, that cuts a lot of things out. So that cuts out like more host level things, like, but it doesn't protect you from other containers things at all, obviously.
Can you elaborate on what the log reader type is used for?
So when you want to read, I mean, so the CRI logs today are written down with that type. So say there's some process that is ingesting those logs, it can run with that type, and it will be able to read those logs.
Would that need a host path mount?
Yeah. For ingesting the logs from the CRI location would need a host path mount.
I feel like we probably shouldn't allow that in baseline then, since we don't allow host path mounts.
Yeah, the container itself reading the CRI logs, it seems like host level.
Yeah, we can take that out. Though let me check if there's any other logs that we write with that label by default or not. This is the one I'm sure of.
I'm trying to think of the things that access container logs. Like typically it's the kubelet accessing
Right. Yeah.
the logs, not the container itself.
Yes, kubelet has access because it is running with the privilege enough label. Yeah.
Or your log exporter, but in most cases I would expect the log exporter to be running with host level privileges.
Yeah, not baseline, no host mount. Yeah.
The KVM type, I guess we can leave in. That would probably fall under runtime class exceptions in a lot of cases, but maybe not. And then the init type is needed if you're running systemd in like a fully containerized systemd?
Yeah, as a PID one for your container.
Okay. How come that is needed in that case?
So systemd has some requirements, and because of which we had to create a special type just for it.
Got it.
So that bit about, sorry, I had the mute button issues. The bit about container init, does it make sense to run containerized systemd inside of restricted pods? That's a thing I just don't know the answer to.
Don't see any reason why not.
Yeah, I think you should, right? It's like if you want to benefit from systemd features, I don't see why not.
Okay, so if it's safe to turn on and restricted, we would consider turning that one on as well, right?
Yeah, so what I'm hearing is let's drop log reader for both baseline and restricted, and then the restricted policy would just match the baseline policy.
Okay, based on what I've heard here, and this was very helpful for me, I think that makes sense.
Okay, yeah. And the KVM type, right, it'll be useful because like a bunch of new container runtimes popping up, like people experimenting with hybrid VMs and containers, and that is a good policy to use for such runtimes.
Any other thoughts or concerns on SE Linux, or can we mark this as resolved?
That answers all my questions.
Yeah, same here.
I guess the last question I have on this is, should we update the pod security standards with the same advice?
I would like to see those be more deterministic. So, yeah. I would think so.
Okay.
Yeah, I'll open that here. We should make sure all the implementations follow the same standards.
Yep, sounds good. All right, I suggest we talk about volumes next, since we were just kind of touching on volumes a bit. David, I think you raised this. Do you want
to? I'm actually, I guess I have two concerns. One is that I don't actually know offhand which volume plugins are allowed for baseline and restricted. And then I'm not sure how we're handling CSI drivers or whether we would handle flex volumes at all, or whether we just consider them like, now you're too old, move to CSI.
So for baseline, the only restriction that we place is that you can't have host path volumes. Everything else goes.
Does that include any CSI driver?
Yes.
Okay.
And then for, let me just share what we say for restricted, and then we can talk about whether this is the right restrictions or not. For restricted, we essentially say you're allowed to use the atomic, I think it's called like atomic writer, basically the ephemeral volume. So empty dir, secrets, config maps, downward API, projected volumes, all those ones. And then for everything else,
Persistent volume claims, yeah.
Yeah, so for everything else we say, use a persistent volume with a persistent volume claim.
Okay.
Is your question that CSI drivers, do they use host path or not?
Well, a CSI driver, could do anything someone wanted, whether that's a good thing or a bad thing, and whether baseline should assume that any CSI driver is acceptable to use. It's not immediately. Yeah, I don't know that I think.
I think most CSI drivers do require host path mount for the kubelet root directory, though.
The driver itself does,
right?
But
what it grants access to,
right?
Like,
so, I mean, most of the CSI drivers, or at least most of the initial ones, are out of tree implementations of the cloud storage volumes that are disallowed here, like GCE direct access to GCE persistent disk, and cluster or Ceph or Azure File or Azure Disk. Like, there are CSI drivers for those things, and so if you allowed using a CSI volume but forbade Azure File and Azure Disk or GCE persistent disk, like, that would just let you use those things via their CSI drivers.
And here's where my knowledge ends. Like, is a CSI driver somehow better enough we should do that, or are we going to say, like, no, these things are roughly equivalent? And
my take on this is that kind of like some of the other, it's sort of a similar case to some of the other extension points that we talked about, where if you have a CSI driver, first of all, your cluster administrator or someone with administrative privileges had to have installed that. So if it's available, then someone with elevated privileges already made it available. And then at that point, we can say, well, if you want, if this is a privileged volume, if you want to place additional restrictions on this, then that CSI driver should ship with, or the administrator should set up additional policy restrictions through admission control.
So you would allow CSI?
In baseline.
In baseline. Okay. Well, I mean, we allow most of these things in baseline. So for baseline,
so similar. I think
allowing CSI makes sense if we're going to allow all these other things. For restricted, disallowing CSI means that some uses of CSI, which are closer to the secret config map variety, you wouldn't be able to use anymore.
That's right.
It seems unfortunate to me. Can we consider a way to indicate whether a particular I can't type and take note. I can't type and talk at the same time. Can we consider whether there's a way to allow a cluster administrator to indicate that a particular CSI driver should be allowed or restricted? Like, for instance, I know of one where the idea is I want to have a cluster admin specify that this config map can be mounted using the CSI driver specifying it. And it's basically like globally sharing a config map. The goal would be to have that turn on for restricted users, so they'd be able to use it. That seems fairly reasonable. I'd like to make that use case possible.
This is the sort of thing that we've been trying to avoid.
Yeah. I'm trying to remember, like, parameter-wise, if we, like, for something like the secret CSI secret driver, like, would allowing a pod to fully spec out a CSI volume give it full control over all of the parameters passed to the driver in a way that would let it pull things that maybe weren't supposed to be granted to it?
I think the way we are controlling that is by using RBAC on the provider class, CR, custom resource, since that's namespace. So the idea is if you have access to create the provider, the secret store provider class custom resource in that namespace, then your pod can reference that. Does that make sense?
Maybe. I can't tell how much control they have over all of the parameters plumbed through.
Now, a CSI driver actually is represented by an API resource, as I recall, right? Like, could we not annotate those and say, yeah, a cluster admin created it, and it's created because, I don't know, probably someone provided it, and they could say, I know that this one, the way it works, is safe to be added to restricted for the goals of restricted. And we could avoid configuration on like a per cluster level. Like, yeah, I'm fine tuning how my, restricted baseline privileged works. Instead of like that, we would associate it with the CSI driver itself.
Maybe. I'm trying to think of all of the inputs to evaluating policy. Right now, it's just namespace and the object being admitted. This pulls in another set of stuff.
Well, or I mean, if we put this as a peer to a runtime class, it could be in that config file, which is not as flexible, but does at least provide a way. If you own the cluster, you can say restricted people can use this.
Excuse me.
You can have a secret or persistent volume CSI, persistent CSI volumes, right?
Yes. Yeah, I was kind of wondering, either like for uses like this, would it be possible to do it as a persistent volume? I don't know. Pods have also added the ability to have an ephemeral volume source that goes through like a PV cycle. I'm a little skeptical about the performance of that. Like every pod that spins up spawns a PVC, which gets a PV provisioned, which then mounts in and gets cleaned up on teardown. I'm not super thrilled about that being the story. It would at least be interesting to see if something like the secret driver could be used in a reasonable way using one of those two mechanisms.
I've got another example of, I can find the repo after this, but I got another example. This came up because someone said, hey, I have this CSI driver, and like, do I want your CSI driver? Oh, your CSI driver is pretty cool. And then it was, wait, I'm not going to be able to use your CSI driver.
Based on what I'm hearing here, I think I'm going to propose that we proceed with the restrictions that we have today. And I think this is something that we should continue to explore. I don't think that this decision needs to block alpha.
The fact that CSI is allowed by baseline means that unless you are really locking down your namespaces and make use of this, I am on the fence about it in restricted. Yeah.
I mean, like, I guess I have come up with multiple cases of a CSI driver for this. Like, would we have built a CSI driver to if we did not have the ability to bake projected volumes in, would we have tried to do it based on a CSI driver or projected tokens, right? I think we would have, right? Like, yeah, I want to inject. I mean, it's an easy way to inject without fanning out data to every namespace, right? Like, if I had it to do over again, would I avoid placing the config map containing here's how you connect to every or to the QAPI server in every namespace and duplicating it everywhere? I probably would have.
So for something like that, I wonder if a persistent volume claim, like, would that work? Could that be the thing in the namespace that says, I want to make use of this thing, and it can reference a PV that has a CSI implementation? That's what I'm wondering.
Okay. I can admit to not having tried that.
Yeah, I don't know. I think that the parameters is probably what it comes down to, and like control over those parameters, and that's definitely a double-edged sword. Like, if you give a user control over parameters, they can set sensitive parameters to bad things. And if you don't give them control over parameters, then it's very hard for them to like express what they want, and you sort of get into like needing a ton of persistent volumes.
Now that varies between what a CSI driver is doing. I mean, there's some CSI drivers where no matter what you pass them, they're not going to be dangerous. They can't be dangerous because of the way they're designed. And it's a real shame not to allow those in restricted, because I know that I want to use them and I know that I won't be able to.
But by the way, I haven't heard too many people complain about this. So I'm wondering if we should maybe gauge like how many people want to be able to use CSI as part of when they have restricted.
I would guess that not many people are running in a cluster that is enforcing the restricted pod security standard.
But in OpenShift we do, and we do want to be able to mount, say, a particular CSI driver, right? We have one being created now, or that exists now, and we're looking at using it. And this would stop us from being able to run restricted. Unless we find a way to run it with through the PVC, and I've never tried to do that before. I'm looking at the API now.
Yeah.
So for Secret Store CSI, we actually started with PV and PVC, and then we moved to inline because it was easier to use for users, so that they don't have to like go create a PVC every time.
Did they need to express things that were not on the PVC in order to use it?
I think the CSI capabilities, you would have to pass them in via the CSI APIs. So much like any other, like you would have to provide that in the inline pod inline as well. So same there. Let me see if I can find an example.
It feels like the decision here comes down to Either we allow it in baseline, and we say if your CSI driver is elevating privileges above baseline, then you should include an admission controller that blocks it. So for instance, something that gives access to host paths. Add an additional third-party admission controller or policy preventing that for baseline and restricted. Or we allow CSI for restricted, and we say that most CSI drivers, unless they're kind of fitting in that ephemeral use case, should block, should have that third-party admission policy blocking access to restricted.
It seems like you could have a policy where the default take no action is exactly what you described for baseline, but a CSI driver that is known to be safe for restricted could be added to exclude this, similar to either a runtime class. Well, yeah, similar to a runtime class. That's probably the most straightforward thing we have to compare it to.
The thing that I'm not thrilled about, like inspecting API, like I don't want it to be stateful in its evaluation. Like if you know the policy level you want to apply, I don't want you to have to look at other things in cluster state to decide whether a particular object is good or bad. So
yes.
Like side loading annotations from CSI drivers.
And so the runtime class is in the admission configuration file, and that seems okay to me. I mean, you don't change these very often. CSI drivers seem to fall into a very similar case.
Yeah, I just linked to a PV example.
Yeah, the volume attributes would not be accessible to someone who only had the PVC or the ephemeral driver. And actually, those attributes are good examples of the types of things I wouldn't want a restricted pod being able to set. Like,
yeah, I'm not asking for that one in particular.
Yeah,
like alternatives exist.
Yeah.
Trying to find a link to set alternative now. I'll try to find it sometime after this or while we're talking, but I found the project, but I didn't find a short example.
I will add an unresolved section for this with some of the options that we discussed here.
There's a CSI host path driver. Do we special case that one as excluded for baseline?
No, we tell the cluster admins not to install it.
Okay.
That's one of those examples where like you can do anything in a CSI driver.
Even things you shouldn't do.
Yeah, you could add a CSI driver that lets you exec arbitrary code as root, given the right parameters.
Might format my API server hard drive CSI driver.
So I think in those cases we just say like this is something that's controlled by the cluster admin. Like you should know what you're doing if you're installing this. We can encourage CSI driver authors to ship a webhook admission controller or kind of suggested policies along with them. Okay, I think I'd like to move on to the capabilities discussion in the interest of time. And I think we can kind of follow up on this, the volume discussion later. Everyone okay with that?
Yeah, you said you were going to add an unresolved section and pull in some of these details. That's helpful.
Yeah. Do we want this alpha blocking or beta blocking?
I will have pretty significant difficulties turning this on to try the alpha without this feature.
Even if it's allowed in baseline?
Well, yeah, OpenShift runs restricted by default, always has. And has been able to do so, doesn't have any plans to change, really.
If you don't have a lot of current use of the CSI inline volume, it seems like you could still evaluate the alpha for like all the other uses. Maybe.
I mean, I'm looking at this sort of feature being turned on by default soonish, which does not correspond well.
Okay.
And I can't promise like I can't promise a delivery schedule. How's that? But it is not far off.
Okay, I'll put it down as alpha blocking for now. Maybe follow up. Okay, the capabilities discussion hopefully can be a little easier. So let me pull that up here. The baseline policy for capabilities is adding additional capabilities beyond the default set must be disallowed. The problem is that Kubernetes doesn't define the default set. Docker does, and we sort of assume that's the default set. The question is, do we want to hard code the Docker default capabilities and allow adding a capability that's in that default set? Or do we just want to say you cannot add any capabilities? You can only, so basically that, where is it? The capabilities.add field is completely blocked. Setting anything in there, you can only add .remove. The trade-off here is being able to add capabilities that are already in the default set is nice if you want to take a more like kind of explicit allow list approach, where you say drop or remove star, which removes all capabilities, and then allow or add only the ones that you know you need. The problem with this approach is it means that runtimes can't customize the default set, which you can do through containerd, probably cryo. So on the flip side, we say, you can't ever add any capabilities. So what you get in the default set is, as defined by the runtime, is what you get, and you can remove additional capabilities from that if you want. I prefer.
When you say container runtimes couldn't customize the default set, they could customize it like for themselves. Like if you didn't specify anything, or if you only added, they could customize.
Yeah, so
they couldn't customize what was allowed by this policy.
Right. So you could. So they can still customize the default set, but for instance, if you wanted to say we don't allow capnet raw, I can set my containerd configuration to not include capnet raw. But if we hard coded the defaults, then a pod could just add capnet raw back in the baseline policy. I definitely think that forbidding add makes sense in restricted. Since we don't allow it to run as root, there's not really any reason to add a capability. And we don't handle the, I can never remember the name for the term, the flexible non-root set of capabilities.
Oh, well, so user namespaces are coming, and in that, I mean, under a user namespace, technically you can enable all the capabilities, and they are tied to your user namespace. So we'll have to reconcile.
Once we have user namespaces, I think we'll need to reevaluate a bunch of these.
Yeah.
Controls.
This is one of the reasons, like, I'm happy to express these checks in code rather than declaratively, so that when we get things like user namespaces in the glorious future next year, it's always been next year, when we get it, we can actually say, like, for a container that has user namespaces set, like, this is what's allowed. For one that doesn't, this is what's allowed. That will make it easy for us to do that when that time comes. So I am out of my depth capabilities wise, so I will defer to Tim and Manal and whoever else understands them.
Yeah, I agree with Tim that on the restricted, it probably makes sense to not allow an add. Like, you're not allowed to add anything. But I think I don't know how to handle the case where you want to drop everything and just pick one or two from the default set. Like, how common is that today?
I think it's probably not that common. I've seen it used as like a best practice in a few places, but
yeah, that won't work unless Kubernetes has knowledge or defines a default list, right?
I mean, if the choices are between don't allow add at all or allow adding like the most widely used set of defaults, like would taking the most widely used set of defaults, the Docker defaults that were linked, like cover most of the places where people are dropping all and then adding back a couple? Like, for someone to get in trouble with that approach, their runtime would have to have customized things, and they would have to be dropping all and then adding back a customized thing that's outside
what the runtime had.
Normal Docker set of default.
So, Mernal, do you know whether the cryo list agrees with the Docker list?
Cryo list was initially, I mean, at least it was smaller. I haven't checked the Docker list recently. And from the list I posted, like, even netbind service can be dropped because now there is a sysctl that we can enable that gives you netbind service. So that's a shortest list.
I mean, I guess I'd want to know how different they were before I tried to say, like, surely we can pick a small list from them.
Right.
So everything Renal posted, Chum, Docker override, set ID, owner, set group ID, set UID, set PCAP, netbind service, and kill. All of those are included in the Docker default list. The Docker default list includes another 7 that are not present in that list. So if the Docker, because you can always layer on another protection on top of this to crank down permissions tighter, if the Docker default list includes the defaults from other container runtimes we see, that seems like an okay list to work from for baseline. I agree, restricted adding.
Yeah.
Doesn't make
sense. Capnet raw is the main one I would.
Yeah, I think that one is
to drop.
Yeah. Does Docker default still include it? Jordan?
Yeah, it does. That's the main one where it's like, I wish that Docker defaults didn't include it. And I think that's widely dropped.
Yeah. Yeah, I think rest all are okay. Netraw is a dangerous one here.
Is netraw the one that people add so they can use ping?
Yeah, and now there is a workaround. You can have a sysctl to enable just the ping.
Yeah. Okay.
I mean, I guess having an admission plugin per runtime is not bad for baseline.
If that becomes like widely considered the way to use this, then I think we've failed. The whole point of this was to have an option built in so that you don't need a admission plugin.
I mean, well, I guess I don't know what all these do. And I suppose if Mernal told me to turn on all the ones that Docker turned on, I wouldn't know to tell him no. But I don't know if everyone would share that opinion.
So forgive my ignorance. If you don't add netraw, kept netraw, does that mean you don't have it, or does it depend on what container you're running?
You mean you don't add it to the default, or you mean in your
if you
pod
don't
spec?
explicitly add it in the pod spec, if you don't say capabilities add or netraw, does that mean the container, and you run on Docker, which has this set of default list of capabilities, does that mean you will not have netraw, or it depends on like something in the image?
So no, it depends on how the runtime is configured. So like runtime, if it has it in its default list, it will give that to you. Doesn't matter what your container image has in it.
Rita just gave us a time check. I would like to get to the Windows discussion. I think we can kind of follow up on the capabilities on Slack or offline. So the outstanding question around, or discussion around Windows is how do we decide if a pod is a Windows pod? What we had previously said was that at least for the alpha, we would sort of punt on this and say there should be a Windows runtime class and exempt the Windows runtime class in a cluster that uses it.
Yeah, so I think Mark's concern with this was just having to do extra configuration. And initially he thought it wasn't supported from the Docker side as well. It looks like Docker does support it, and then by using the handler of Docker. And then for needing additional configuration, I looked into it, and there's a handler, there's a default handler for all of the deployments, so we could add the runtime class, and that if we tell folks to call it Windows, then they would be able to trigger off of that. Or I guess the exemption is it's open, so you can call it whatever you want, and you'd be exempted by it.
So you are open to sticking to the runtime class restrictions then?
Yeah, I think so. Mark is out this week. I'd want to cover it over with him, but I think his biggest concern was that you'd have to go kind of modify the nodes to add one of these runtime classes and modify the container D configurations, which isn't, I don't think is the case, because there is a handler that's there by default with their standard containerd deployment.
There is one concern that came up around the use of runtime class, which is suppose I have a hybrid cluster running Windows and Linux nodes, and everything is running Docker shim. I know Docker shim is going away, so maybe this is not something to worry about too much. But the same would apply to, say, containerd with the same name for the runtime handler configured everywhere. So then in this scenario, I'd have two runtime classes, Windows and a Linux, or just maybe just the Windows one and default to the Linux. And that Windows runtime class would have the Docker default handler set, and then also some scheduling constraints to make it land on those Windows nodes. If we said that Windows was exempt from this policy, then I could create a Windows pod as an attacker or malicious user. I create a pod, I assign it the Windows runtime class, and then I explicitly set the node name to make it land on one of the Linux nodes. It gets exempted because our policy thinks it's a Windows pod, and it ignores the scheduling constraints because I set the node name manually. And then because it's using the Docker default handler, it gets to run without constraints on the Linux one. So the issue here is mostly having a runtime handler that works everywhere. And then also not having, I mean, ideally we would have a separate admission controller for Windows that says you're running with the Windows runtime class, so you're not allowed to set any of the Linux security options. And that is sort of the assumption that if you're exempting a runtime class, that you're handling policy on that through a third-party admission controller. But I did want to point out that concern.
So it's essentially by using a combination of runtime classes and node selector, or not node selectors, but node names, you could potentially schedule a pod on Linux that was technically exempt from Windows. Is that?
Yeah. Yeah, and the issue is sharing a runtime handler name across both Linux and Windows nodes.
That'll happen in the Docker shim scenario.
Yeah. Docker shim is maybe even removed in 121. It's certainly deprecated, so no, not removed.
Deprecated, not removed.
Yeah, 124 is when removal is targeted. Right?
There are issues even if you try to check the security context bits on a pod, right? You still be able to mount these volumes that are restricted, and you want to get checked, right?
Mm-hmm.
If you were exempt, we wouldn't even know to look at you. So I guess we would be asking the secondary admission plugin to also be checking for those.
There's also talk of adding Windows-specific security context options. As soon as we have a standard way of identifying Windows pods, we can actually build Windows policy into this admission controller that we're designing, which I think is the ideal solution, long-term at least. We are over time, so I need to drop off. I'd like to be respectful of everyone else's time as well. Sorry we sort of ran out of time for the Windows discussion. I think we do need to continue having these, so I'll make sure that we put Windows at the top of the agenda next time. So thanks everyone for coming.
Thank you. Bye.